Hey everybody, so this is part one of the worksheet. So I'll be going over pages 1 and 2 of the chapters 2 through 4 practice worksheet. So let's get started. Number 1, consider the market for homes in Southern California to initially be in an equilibrium. The tax rate for households in California increases. What shift will take place in the housing market? Does the demand or supply curve shift? So first we want to analyze what happens to the market, what happens to supply or demand. All right, so in this case, we're given that the tax rate for households in California increases, so therefore we know that that's going to affect the demand curve. So if the tax rate for households increases, well, that means that the demand for housing is going to go down because the taxes increased, right? So now these people have less take-home income, meaning their demand is going to shift to the left, right, or down. So let's mark our initial equilibrium right here. So this is P1, Q1, right, and then this is demand 1. So for demand shifts left, it's going to go this way. This is demand 2, right, shifting this way. So now our new equilibrium is point right here where D2 crosses the original supply curve. We're going to mark this. This is price 2. And then we have Q2. So we can conclude that price goes down and quantity goes down as well. Let's move on to number 2. So number 2, now consider that the tax rate for households in California increases and the government lowers the tax rate for housing developers that are building new homes. Considering the aforementioned facts on a demand and supply graph, how will the equilibrium of homes change? So this is tricky, right? Because you're given a graph that already depicts the shifting that's happening. So again, we want to determine what happens to demand and supply, right? So we're still given the same thing. The tax rate for households in California increases, and now the government lowers the tax rate for housing developers that are building new homes. So if you look at this first sentence right here, if the tax rate for households in California increases, demand will decrease because the same as back up in number 1, their take-home income is now less because they are taxed more. That being the consumers are being taxed more, so the consumers have less take-home income, therefore the demand is going to decrease. But at the same time, the government lowers the tax rate for housing developers that are building new homes. So this means if housing developers have a lower tax rate, well, in that case, they're going to want to build more homes, right? Because it's cheaper for them now. So the supply goes up. So now with this graph, we want to determine where were we before the shifting and where are we going to be after the shifting. So in order to do so, we kind of want to work backwards, right? So we know that demand is going to go down. So the only way for the demand to go down is if we're either at this point or at this point, right? On this demand curve, we can only go down because we want to decrease demand, so we know we're going to be shifting this way, right, arrow this way. So now the only thing that we have to determine is supply increases, right? So we know we're going to be at either this point or this point. So if we're here, that's true, we can increase supply, right? Because if we start here, we cannot increase the supply. So we know that this is A is where we start, right? So we'll put here A is where we start. And again, that's because we know we're going to be decreasing the demand and increasing the supply, right? So if we do that, if we move this way, we decrease the demand and then we increase the supply, we're going to be down here. So B is where we end, right? So again, if you want to draw initially, right, this is P1, this was Q1, right? So when we shifted, after demand decreasing, supply increasing, we were here at P2. But what happened to Q? Well, we're still at the same place, right? Because we aren't sure how far the supply or demand shifted. We just know that they shifted in these directions, right? But we cannot conclude whether or not quantity increased or decreased. Because if you think about it, supply increased, right? But we know that demand decreased, but we don't know by how much it decreased. So it really could have been anywhere along this line, right? So it could have decreased this much, this much, this much. So we are unsure where we'll be. So because of that, we're going to say that Q is ambiguous because it still looks like it's approximately at the same spot, right? Depending on how far it shifted. It could have shifted anywhere before, or it even could have shifted further down this way, right? So our new demand could be anywhere from here to here, right? So we don't know. So we can conclude, so P decreased for sure, right? Because P1 is up here, P2 is down here. And then Q is, ambiguous, right? Okay, so number 3. Let me move this upward real quick. In the past 5 years, the cost of producing 4K TVs has decreased. At the same time, many consumers are opting to watch TV programs on their smartphones, tablets, or laptops. Considering these 2 facts, assess the following claim. The price of 4K TVs are decreasing, but it is not clear whether the quantity of 4K televisions bought and sold has increased or decreased. So you want to do the same thing again, right? You're going to want to determine whether supply increased or decreased and whether demand increased or decreased. So let's begin with our demand, right? So if we look at this, we can see that it talks about our demand here. Consumers are opting to watch TV programs on their smartphones, tablets, or laptops. Consumers have to do with the demand, right? So if consumers are going to be watching TV on other devices, you know that the demand for TVs is going down because they're using their laptops, iPhones, or whatever, whatever instead. What happens to supply? Well, in the past 5 years, the cost of producing 4K TVs has decreased, meaning supply increases. Because remember, cost of production, if it gets cheaper to make a TV, then the supply goes up, right? So let's label our initial equilibrium. So this is P1, Q1, before the shift, right? And then after the shift, so we decrease demand. Gonna go this way, right? So we label this demand 1, this is demand 2. And we increased our supply, right? So we go from supply 1 to supply 2. And we can see that our new equilibrium is going to be right there at P2. And then Q, as you can see, is still the same, right? We don't know if it moved, just a little bit or quite a lot. So so Q is considered ambiguous, right? So we can tell that P decreased, but Q ambiguous, right? So in this case, the statement is true, right? Because the price of TVs are decreasing, yep, but it is not clear whether the quantity bought and sold have increased or decreased. That is true. Okay, let's move on to the second page. Okay. So we're going to use the following information and table to complete 4, 5, 6, and 7. Suppose that an economy produces only the following 4 goods and services: textbooks, smartphones, tacos, and avocados. Further, we're going to assume that all the avocados are used in the production of tacos. So right off the bat, right, assume that all of the avocados are used in the production of tacos. We can get rid of this column right here because that's just going to throw us off. We're not going to want to use this column in our calculation because the avocados are used in the production of tacos. So we're not going to count an intermediate good. You can review that in the chapter as well. So right off the bat, we're going to want to calculate nominal GDP in year 2 and 3. So let's start by writing the nominal GDP formula, right? So nominal GDP in year 2 is equal to the summation, right, of the quantity times the price in year 2. Because the nominal GDP is using the quantity times the prices in the current year. Remember that? So for year 2, right, if we're summing the prices and the quantities, we're going to be doing 120 times 20 plus 75 times 60 plus 600 times 6. Okay, so when we find that, I've done the calculations in advance to save time. So once we calculate that out, we're going to get 10,500. This is the nominal GDP in year 2. Let's do the same for year 3. Nominal GDP in year 3. So we're going to do the same thing. We're going to do the summation of the quantity times the prices in year 3, because again, we're doing summation of the quantity times the prices in the current year. We're talking about year 3, right? So we're going to do these calculations. We're going to use this column, right? This times this, this times this, and this times this. So we're going to do 130 times 25 plus 100 times 75 plus 700 times 7 is equal to, right? Multiplying these out and adding them, this gives me 15,650. So it's as simple as that, right? Nominal GDP is just summation of quantity times prices in the current year, right? So we're in year 2, that's why we're using the price in year 2. Okay, hopefully it makes sense so far. We're gonna move on to number 5. I'll try to keep the table on here at the same time. It might be a little difficult. So how is real GDP different from nominal GDP? Right, so we're going to want to find the real GDP in year 2. So it is very similar. We're going to be summing the summation of the quantity times prices, not in the current year, but in the base year, right? So this is the price in year 1, because going back up to the table, right? Year 1 is your base year, and the real GDP is asking us to find the quantity times the summation of the quantity times the price in the base year. So now I'm going to be going up here, right? I'm looking at year 2, so I'm using the same quantities, but instead of using these prices here, I'm going to be using the prices from year 1, the base year. So this is going to look something like 120 times 10 plus 75 times 50 plus 600 times 5, and I've calculated that in advance. It looks like that is 7,950. We're going to do a similar thing for real GDP in year 3. We will be summing quantities times prices in the base year, year 1, right? So we're using quantities, in here we use the quantity year 2 because we wanted the real GDP of year 2. Here we will be using the quantity in year 3, right? Because we want the real GDP in year 3. And we're going to be using still the price in the base year. So what is our quantity in year 3? Well, this is going to be 130 times 10 plus 100 times 50 plus 700 times 5. So then this gives me 9,800. Right, so it's as simple as that. The difference between nominal and real GDP is that nominal, you're using the prices in the current year, whereas with real GDP, you're using prices in the base year. Hopefully that's clear. Okay, these are going to be the last 2 questions for this video, and we'll have a part 2 video going over the other 2 pages shortly. So the next question is asking you to calculate the GDP deflator in year 2 and 3. So we know that the GDP deflator formula is as follows: GDP deflator in year 2, right? This is equal to the nominal GDP in year 2 divided by the real GDP in year 2. We're going to multiply this by 100. Right, so of course we can just go back up and look at the numbers that we already have. So this is nice because we are looking at something like 10,500 divided by, right, because that's our nominal GDP in year 2 divided by real GDP in year 2 gives me 7,950 multiplied by 100. This gives me 132.07%. Right, and again, what the GDP deflator tells me is it just measures the level of price changes over time. Right, so this is measuring just over time, how are my prices changing? Are they increasing? Are they decreasing? So GDP deflator year 3 is going to be the same formula: nominal GDP year 3 divided by real GDP year 3 times 100. So my nominal GDP in year 3 is 15,650 divided by my real GDP. Oh, you can't see this. I just realized. Hopefully you can see it now. Divided by my real GDP in year 3, which is 9,800. Multiply this by 100. This gives me 159.69%. So our price levels have increased between these years, you can see. So now we're going to calculate, lastly, calculate the inflation rate between years 2 and 3. Right, so inflation is just prices getting higher every year, whereas deflation is prices getting lower every year. So our inflation rate, we want to find the inflation rate between between years 2 and 3, right? So I'm going to do inflation rate year 2, comma, year 3 is equal to the GDP Deflator year 3 minus GDP Deflator year 2 divided by GDP Deflator year 2. Multiply this by 100. Plugging and chugging from above, right? So sorry, this is 159.69 minus 132.07 divided by 132.07. Multiply this by 100. So this gives me 20.91%, right? Prices are just, or inflation, prices are 20% higher, right? Inflation rate. So it means prices have increased. So hopefully this made sense. If it did not, leave comments in the video below. I will be uploading the part 2 to this, being the 3rd and 4th pages to this worksheet. Thank you.